In this video, we are going to go over the Junior Certificate Ordinary Level Mathematics Exam, Paper 2, from the year 2015. Question 1. The songs on Gavin's phone are shown in the table below. So we're shown the singers and the number of songs, with the first one missing. Gavin has 30 songs in total. Find how many songs by Usher are on Gavin's phone. So Gavin has 30 songs in total. So that means however many songs by Usher, let's call that X, plus 15 plus 4 plus 3. So X plus 15 plus 4 plus 3 has to equal 30 songs that he has on his phone in total. So simplifying the left-hand side, we get X plus 15 plus 4 is 19, plus 3 is 22. So X plus 22 is equal to 30. We can then subtract 22 from both sides to get that X is equal to 8. So Gavin has 8 songs by Usher on his phone. Part B. Gavin plays a song at random. Find the probability that this song is by Hozier. So we know that there are 30 songs in total, and we know that 3 of them are by Hozier. So the probability of any event is equal to the number of successful outcomes divided by the number of possible outcomes. So what that means is the number of outcomes that we want, in other words, a song by Hozier, which is 3, divided by the number of possible outcomes. That is the number of all outcomes. So each song is an outcome, and there are 30 songs in total. So there are 30 possible outcomes. So the probability that this song is by Hozier is 3 over 30. And that can be simplified to 1 over 10. So that answer goes in here, 1 over 10. Part C. Find the probability that this song is by Ed Sheeran or Pharrell. So this time, the number of successful outcomes are the number of songs by Pharrell plus the number of songs by Ed Sheeran. So that's 15 plus 4 is 19. There are 19 successful outcomes. The number of total outcomes is 30. So our answer for part C is 19 over 30. So in this box we put 19 over 30. Gavin plays a song by Ed Sheeran and then plays a song by Hozier. In how many different ways can he do this? So he has 4 songs by Ed Sheeran and 3 songs by Hozier. So the number of ways he can play a song by Ed Sheeran and then Hozier is 4 multiplied by 3. So the number of songs by Ed Sheeran multiplied by the number of songs by Hozier. So 4 times 3 is equal to 12. So there are 12 different ways Gavin can play a song by Ed Sheeran and then a song by Hozier. Question 2. When the Irish rugby team played in Croke Park, a rugby pitch was made inside the GAA pitch. The GAA pitch was 145 metres long and 90 metres wide. So it is shown here, 145 by 90. The rugby pitch was 120 metres long and 70 metres wide. So it's shown inside, 120 by 70. Find the area of each pitch. So for the GAA pitch, the area is going to be the length times the width. So the area is going to equal to 145 multiplied by 90, the length times the width. So that's 145 multiplied by 90, which is equal to 13,050. And because Both sides are measured in meters. That is 13,050 square meters. Next, we want the area of the rugby pitch. So the area again is going to be the length multiplied by the width. So this time it will be 120 multiplied by 70. So 120 multiplied by 70. That is equal to 8,400 square meters. Part B, what area of the GAA pitch was not used for rugby? So we're being asked what is the area of this region around the rugby pitch within the borders of the GAA pitch. So whatever this area is, that will be equal to the area of the overall GAA pitch minus the area of the rugby pitch in the middle. And then we'll be left over with the area we're looking for. So the total area of the GAA pitch is 13,050 minus the bit used for rugby, 8,400. So 13,050 minus 8,400 is equal to 4,650 meters squared. So there were 4,650 square meters that were not used for rugby. Question 3. Calculate the size of the angle marked P in the right-angled triangle below. So given a triangle, we know that the three angles in a triangle always have to add up to 180 degrees. So the angle P plus the right angle, which is 90 degrees, plus the angle we're given, which is 22 degrees, has to be equal to 180 degrees. So we can subtract 90 from both sides straight away. We get P plus 22 is equal to 90. So we're subtracting 90 from this side and from this side. So 180 minus 90 leaves 90 left over. And subtracting 22 from both sides, we get that P is equal to 68. And because P is an angle, that is 68 degrees. So the angle P is 68 degrees. Part B, draw the image of the triangle below under axial symmetry in the line K. So we're given a triangle and we're given a line and we're told to draw its image under axial symmetry. So what that means is the reflection of this image in this line. So whenever we reflect something, each point goes a certain distance to the line and then the same distance out the other side. So if we take this point, it'll go over to here. If we take this point, it'll go to here. And if we take this point over here, that's going to go all the way over to here. So now we just have to join these points together. And we get the image of the triangle under axial symmetry in the given line. So as you can see, it's being reflected onto the other side. So every point in this triangle goes to the line and goes the same distance out the other side. So we did it for these 3 points, but it would be the same if we did it for any other point. So if we say chose a point here, it goes 2 squares to the line and 2 squares out the other side. If we chose, say, a point here, it goes however many squares to the line and the same number of squares out the other side. Part C. Write down the length of the side opposite the angle or in the triangle shown. So we're given a triangle, we're given an angle, and we're asked for the length of the opposite side. So here's the angle, so the opposite side is this side here, the one that's opposite it. So the opposite side has a length of 12 meters. Part 2 says use Pythagoras' theorem to find the length of the hypotenuse. So that means they want this distance here, the length of this longest line here. So Pythagoras' theorem tells us that a squared plus b squared is equal to c squared, where c is the hypotenuse in the triangle. So in this case, a will be 5, b will be 12, and c is an unknown distance that we have to calculate. So this says 5 squared plus 12 squared is equal to c squared. 5 squared is 5 multiplied by 5, so that's 25, plus 12 squared is 12 multiplied by 12, so that is 144, is equal to c squared. So adding these two terms together, we get 169 is equal to c squared. So c will be equal to the square root of 169, which is equal to 13. Question 4. The diagram shows the number of new cars sold in a garage this year. So we have our graph, shows the number of cars sold on the y-axis from 0 to 300, and it shows months along the bottom on the x-axis. So for instance, January through March, they sold approximately 300 cars. In April to June, they sold 150, and so on. How many new cars were sold in the months April to June? Well, in April to June, there were 150 new cars sold. So 150. In the months October to December, there were exactly half as many new cars sold as in April to June. How many new cars were sold in October to December? Well, in April to June, we just saw that was 150. So half of 150 is going to be equal to 75. So there were 75 cars sold from October to December. Draw in the bar for October to December on the diagram above. So we've got our diagram. We have to go to 75, so that's going to be halfway between 50 and 100. So that's going to be here. So we're going to go this high and mark across the top. So here's the bar for October to December. So there are 75 cars sold in October to December. Part D. When were the most new cars sold? Put a tick in the correct box. So it gives us each of the 4 possible options. So January to March, April to June, July to September, and October to December. And the time period that sold the most cars was January to March, because they sold 300. Each of the other months sold less than that. So you put a tick in the box beneath January to March. Part E. Calculate the total number of new cars sold in the year. So for this, we're going to have to add together the numbers of cars sold in each period. So for January to March, there were 300. In April to June, there were 150. From July to September, there were 200. And in October to December, there were 75. So 300 plus 150 plus 200 plus 75 is equal to 725. That's equal to 725. There's your answer to part E. Part F. Calculate the average number of new cars sold per month, giving your answer correct to 1 decimal place. So the thing we have to watch out for here is it's asked for the mean number of cars per month. Now each period here is not 1 month, it's 3 months. So we'll have to divide by the number of months, which is 12, even though there are only 4 groups. So the number of cars sold is 725, and we want to divide that by the number of months to get the average number of cars sold each month. So the mean will be equal to the sum of the numbers, so that's what we just calculated in the last part of the question, as 725 divided by the number of numbers, which is 12, because there are 12 months in the year. So 725 divided by 12 is equal to 60.41. And they want it to 1 decimal place, so 60.4 is the mean number of cars sold each month. Question 5. One of the following is a description of the mode of a list. Put a tick in the correct box to show which one. So we have 3 different descriptions. First one says the middle value in an ordered list. Well, we know that's not the mode because that's the definition of the median. Second description is the biggest value in a list. That's just the largest value. And the third is the most common value in a list. Or in other words, the most often occurring value in a list. So the third one is the mode. So you'll put the tick in the third box. Part B says write out a list that has a mode and write down the mode of your list. So we can choose any sort of list. I'm going to just choose a short list of numbers. So I'm going to say 1, 1, 1, 2, 3, and 4. So there is a list of numbers, and the mode is the most often occurring number, which will be 1, because there are 3 ones, and there is only 1 occurrence of each other number. So the mode of this list will be equal to the number 1. Now your list can be anything, it doesn't have to be numbers. It could equivalently be a list of brands of car, for instance, or types of soft drink, or people's names. It could be any list as long as there is at least one value that is repeated. And then that value, or the value that is repeated the most, will be the mode. Question 6. The points A and B are shown on the coordinate diagram below. Write down the coordinates of the point A. So the point A is here, so its coordinates are going to be 1, 4. So the x coordinate will be 1 and the y coordinate will be 4. So A will be the point 1, 4. We're told that B is the point 6, 2. And we see that's correct, so 6 and 2. Part B, we're asked to find the length of the line AB, giving your answer in the form the square root of x. So to do this, we're going to take out our formula and tables book, and we're going to turn it to the page with coordinate geometry on it. That's page 18. Now we're asked to calculate the length of a line, or the distance between 2 points is another name for it. And we have a formula for that. Length of the line PQ, it's called here. And the formula is given that the distance from A to B will be equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. So the square root of x2 minus x1 squared plus y2 minus y1 squared. So our values for x1 and y1 will be the point A. So x1 will be 1 and y1 will be 4. So they're the coordinates of the first point. And for x2, y2, they will be the coordinates of the second point. They'll be the coordinates of B, which will be 6, 2. So x2 will be 6 and y2 will be 2. So let's substitute those values into the formula. So x2 is the x-coordinate of the second point, which is 6, minus x1, which is the x-coordinate of the first point, which is 1, squared, plus the y-coordinate of the second point, which is 2, minus the y-coordinate of the first point, which is 4, squared. We take the square root of that. So that's going to be equal to the square root of 6 minus 1 is 5. So that's 5 squared, plus 2 minus 4 is minus 2 squared. So that's going to be equal to the square root of 5 squared is 25, and minus 2 squared is 4. Which is equal to the square root of 25 plus 4 is 29. So the distance from A to B is the square root of 29 units. And this is the form that we were asked for. So it's in the form of the square root of x, where x is a natural number and 29 is a natural number. Part C. C is the point minus 4, 1. Plot the point C on the coordinate diagram above. So we have the point of minus 4, 1. So C will be this point here. So here's our point C at minus 4, 1. Part D says find the slope of the line CA. So the line that goes from C to A. We're trying to find the slope of that. So again, we're going to take out our tables book and we're going to see there's a formula for that. So the slope of any line is given by y2 minus y1 divided by x2 minus x1. So the slope, m, is equal to y2 minus y1 over x2 minus x1. So we have our values for each of our coordinates because we know the points C and A. So this is going to be the y-coordinate of the second point, which will be A. So the y-coordinate of A will be 4, minus the y-coordinate of the first point, that's C, which is 1, divided by the x-coordinate of the second point, which is 1, minus the x-coordinate of the first point, which is minus 4. So that's going to be equal to 4 minus 1 is 3, and 1 minus minus 4 is equal to 1 plus 4. So that will be equal to 3 over, and 1 plus 4 is 5. So the slope of the line CA is 3 over 5. Question 7. We're given the sketch of a triangle with the lengths of the sides labelled as 4, 6, and 8 centimeters. What type of triangle is this? So we want to see, is it an isosceles, a scalene, or an equilateral triangle? Well, an equilateral triangle means all the sides are the same length. And they're not the same length because this one's 4, this one's 6, and this one's 8. So it's not an equilateral triangle. An isosceles triangle means that 2 of the sides are the same length. Again, we don't have that because 4 is not equal to 6 or 8, and 6 is not equal to 8. So it's not isosceles. So all there is left is a scalene triangle, which is when all 3 sides are different lengths. So this is a scalene triangle. Part B. Construct the triangle accurately in the box below. So to do this, we want our compass and our ruler. We're going to start by measuring the baseline of the triangle, which will be 8 centimeters. So we're going to draw a line that is 8 centimeters long. Then we're going to take our compass and we're going to put the point of the compass on the left side of the line. And we're going to give the compass a length of 4 centimeters. Then we're going to swing an arc up this way. Next, we're going to give the compass a length of 6 centimeters. And we're now going to put the point of the compass on the right-hand side of the line. We're now going to swing another arc up to here, so that we can see where the point of intersection is. Now all we have to do is join each of these ends of the line to the given point. And there we have accurately constructed the given triangle. So the base will have length 8 centimeters, this side will have length 4, and this side will have length 6. Part C says measure the biggest angle in your triangle from part B. And write the size of the angle into the box below. So we need to take out our protractor. We can see that this angle is the biggest one because these two are both less than 90 degrees. This one is more than 90 degrees. So we're going to use our protractor. And we are going to measure the angle to be approximately 104 degrees. So the size will be 104 degrees. That is the size of the largest angle. Question 8. The marks that 9 students got on a test are given below. Write out all 9 marks in order from the smallest to the largest. Okay, so the smallest number is going to be 13. The next smallest is going to be 15. Then we're going to have 16. The next smallest will be 18. The next smallest will be 20. The next smallest will be 23. And another 23. The next smallest will be 26. And the largest will be 30. So there are the numbers in ascending order. Part B, write out the median mark. So the median mark means the number that's in the middle when the numbers are placed in ascending order. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers in total. So the middle one will be the 5th number. So 1, 2, 3, 4, 5. So the median is 20. Part C, find the range of the marks. Well, the range is equal to the highest minus the lowest. Equal to the highest mark minus the lowest mark. So the highest mark is going to be 30, and the lowest mark is going to be 13. So the range of values is going to be 17. Part D, the teacher adds 2 marks onto each student's mark. Find the new range of the marks. So now, the range will still be equal to the highest minus the lowest, but this time the highest will be 32 because he's added 2 marks onto each. And The lowest will be 15 because again he's added 2 marks onto each. And that's 32 minus 15. So 32 minus 15 is again equal to 17. So the range is still the same. Question 9. A cube has sides of length 2 centimeters. Find the volume of the cube. So to find the volume of an object, we want to multiply its length by its width by its height. So length by width by height. So it's a cube, so all of these values are the same. They're all 2 centimeters. So the length multiplied by the width multiplied by the height. So that will be equal to 2 times 2 is 4, times 2 is 8 cubic centimeters. Part B asks how many faces does a cube have? So we can count them. It has 1, 2, 3, and then on the back it will have 4, 5, and 6. So there will be 6 faces in total on the cube. So that's the bottom, the top, left, the right, the front, and the back. 6. Part C says draw the net of a cube as accurately as you can. So there are a lot of different ways you can do this. I'm just going to choose one of the most simple types of net. So I'm going to have 1, 2, 3, 4. And then I'm going to have 1 across. I'm going to again have 1, 2, 3, 4. And 1 across. And then I'm going to cross over here and down here. And mark off each of these points and this last one. So what I've drawn is the net of a cube. So what that means is when you fold up this shape, you will get a cube. If you imagine these 4 sides all folding up to become the 4 sides, this part is the bottom, and then this side will fold over onto the top. So that will become a full cube. Now this is not the only net you can draw. There are, I don't know, about 20 different nets that you could draw, but this one is probably the easiest one to draw. Question 10. The photograph shows a water tank in the shape of a cylinder. It has height h and diameter d. These values are marked. So d and h. Using your ruler, find the height and diameter of the tank in the photograph. Give each answer correct to the nearest centimeter. So the diameter is going to be about 5.6 centimeters. So the diameter will be about 6 centimeters to the nearest centimeter. And the height will be about 2 centimeters. So there's your height and there's your diameter to the nearest centimeter. Jenny thinks the actual height of the water tank is 1 meter. Use Jenny's value to find the actual diameter and the actual radius of the tank. Give each answer in meters. So she thinks that the actual height is 1 meter. So on our diagram, 2 centimeters is equal to 1 meter in real life. So what that means is, to go from our values to the real values, we want to divide by 2 and multiply by 100 to get meters instead of centimeters. So, to get the actual diameter, we want to divide our value by 2. So 6 divided by 2 is equal to 3. And then multiply by 100 to get 3 meters. Then the radius is half of the diameter. So we divide 3 by 2 to get the actual radius. So 3 divided by 2 will be equal to 1.5 meters. So there's the actual diameter and the actual radius based on Jenny's estimation of the actual height. Column finds other values for the actual height and actual radius of the tank. They are shown in the diagram below. So now we're told that the actual radius is 2.1 meters and the actual height is 1.4 meters. Use columns values to find the volume of the tank. Give your answers in meters cubed correct to one decimal place. So again, we're going to take out our tables book, and this time we're going to turn to the page of surface area and volume. The shape we're interested in is a cylinder, and the measurement we're interested in is the volume. So we're given a formula that the volume is equal to pi times r squared h. So pi times the radius of the cylinder squared times the height. So that's equal to pi times the radius we're given is 2.1 meters. That's 2.1 squared. And the height we're given is 1.4 times 1.4. So 2.1 squared is equal to 4.41. So that's equal to pi times 4.41 times 1.4. 4.41 times 1.4 is equal to 6.174 times pi. And that is equal to approximately 19.396, which is equal to 19.4 to one decimal place. And our units are meters cubed because we're talking about a volume. Question 11. Use your calculator to find the value of each of the following, giving each answer correct to 2 decimal places. First thing we're asked for is sine of 20 degrees, which is equal to approximately 0.34. So there's our first answer. The second thing we want to find is the cosine of 70 degrees. Cos of 70 is equal to 0.34. The next thing we're asked is sine of 50 degrees. Sine of 50 is equal to approximately 0.77. The fourth thing we're asked is the cos of 40 degrees, which again is equal to 0.77. So we should see a pattern here that for some reason the sine of 20 is equal to the cos of 70 and the sine of 50 is equal to the cos of 40. Part B says hence or otherwise fill in the correct angle below. So we're given the sine of 10 degrees is equal to the cosine of something. Okay, so we want to use the same idea as up above when we notice that the sine of 20 is equal to the cos of 70 and the sine of 50 is equal to the cos of 40 because they're each equal to these values respectively. So we want to see what is the pattern here that's causing that. Well, the thing that seems to stand out is that when we add these angles together, 20 plus 70, we get 90 degrees. And when we add these angles, 50 plus 40, again, we get 90 degrees. So we have to ask the question, is this always true? So when we're given sine of 10 degrees, will that be equal to the cosine of 80 degrees? Because 10 plus 80 equals 90. So let's find out. The sine of 10 degrees is equal to 0.17. Now let's try the cos of 80 degrees, which again is equal to 0.17. So we have that sine of 10 is equal to the cos of 80. So the angle we put in the box here is 80 degrees. Question 12. The graph of the line y equals x plus 1 is shown on the coordinate grid below. So we have the line y equals x plus 1. We're then asked to write down the coordinates of the point where this line crosses the y-axis. So this line crosses the y-axis at this point, at the point 0, 1. So the coordinates are 0, 1. So there's your first answer that goes in this box. Part B then says write down the coordinates of the point where the line y equals x plus 4, so this is a different line, where the line y equals x plus 4 crosses the y-axis. So when you have any line, we have the formula for a general line, y equals mx plus c, where m is the slope of the line and c is where the line crosses the y-axis. So for this line, y equals 1x plus 1, the value of c is 1, so it crosses the y-axis at 1. For the line y equals 1x plus 4, the value of c will be 4, so it will cross the y-axis at the value 4. So the coordinates will be 0, 4. So there's the point where this line crosses the y-axis. Part C says hence or otherwise draw the graph of the line y equals x plus 4 on the coordinate grid above. Well, we know that the point 0, 4 is on this line. We also know that this line, y equals x plus 4, has a slope of 1 because the number in front of x is 1. And the slope of this line that's already given for us is also 1. So the line we're being asked to draw will be parallel to the line we're given. This line is going at 45 degrees. So the line we're going to draw will also go at 45 degrees. So it will go from one corner of each box to the corner of the next box. That will give us this line here, which is y equals x plus 4. Another way we could have done that is by plotting multiple points. So we got the y coordinate is 4 when the x coordinate is 0. But we could have also said, well, when x is 1, what is y? And we would have gotten x is 1 means y is 5, x is 2 means y is 6, x is minus 1 means y is 3, and we would have gotten a series of dots on this line, which we would just have to join to get the desired graph. And we're done. This has been the Junior Certificate Ordinary Level Mathematics Exam Paper 2 from 2015. If you found this video useful, please visit my channel to see more fully worked solutions to both Junior Cert and Leaving Cert mathematics exams.